RSA Protective Technologies introduces the patented Flood Mitigation System, FMS. FMS consists of a series of retractable connected floodwall panels. The system also includes a comprehensive drainage pump and sump system. Passive drains on the dry side pump rain leakage back into the flood zone. The FMS wall raises at a rate of 1 inch per second. For example, the FMS raises to a height of 6 feet in just over 1 minute. A 9-foot wall raises in just over a minute and a half. The height of the panels is entirely customizable based on the application. This video demonstrates how the FMS raises to contain floodwaters. It also demonstrates how the walls retract once flooding is no longer a threat. The materials used in this example are the same used in a full-scale FMS solution. The left side of the screen shows an example of rising water levels due to heavy flooding. The right side of the screen shows how the FMS has prevented any water from entering into the protected area. There are multiple applications for the FMS. The FMS can be mounted inside a sand beach to protect coastal areas. The FMS can be mounted inside levees to protect critical civil infrastructure such as water supply and treatment plants as well as power plants. The FMS can be mounted under walkways to protect municipal buildings and other government buildings. The FMS can also be mounted under sidewalks to protect residential neighborhoods, retirement communities, and other vulnerable areas. RSA's patented flood mitigation system is the industry-leading solution providing protection for coastline, low-lying areas, and critical civil infrastructure. Here is an assembled single FMS unit detailing all the subsystems. Here is the driving system for the FMS. Guide rails and rollers keep the flood walls aligned. Redundant systems guarantees the flood wall stays in the up position. Integrated pipe and pump system for leakage and cleaning from both the flood and safe sides. Discharging into the flood zone. Means to remove leakage from the interior chamber includes water level sensors. Passive drain system in front of the raised flood wall prevents water buildup on the dry side, discharging storm water into the flood zone. Underground pipe system connected to the FMS from the center interior of the dry side, channels storm water to FMS for discharge into the flood zone. Means to clean out interior chamber from sediment and debris, discharging mixed dirty water into the flood zone. Series of horizontal and vertical gaskets work in tandem to keep floodwaters out of the system. Fully assembled motor and cable activated FMS with first retracting and then spring released upstops drives the system up and down. Assembly of precast foundation and flood wall elements assembled at the site. Fully assembled FMS raising and lowering the flood wall shows the cable positioned underneath the flood wall and terminated at the back of the interior foundation wall. The single-panel flood wall test setup uses 9,000 gallons of water against leakage as the flood wall is made to rise and is locked in place. Test water added shows no leakage to the dry side. Manual override using a power tool is used if the primary power source is compromised. Stress analysis for the flood wall system includes values for hygrostatic, hydrodynamic, and impact loading. A finite element analysis is calculated against wind and wave with a high factor of safety. Finite element analysis for the foundation of the analyzed flood wall shows a high factor of safety. Mechanical calculations, including hydrostatic and hydrodynamic loads, aid in sizing the working elements of the system. Geotechnical and structural engineering analysis of a typical FMS project details member sizes and connections to the ground and existing structures to emphasize calculated overturning moments.